Okay, so this video is going to go over pages 10 through 14. So we're going to look a little more deeply into position versus time graphs. Okay, so we're going to start off with this graph here, and I'm going to go ahead and label our parts of the graph. I have line A, line B, line C, and line D. Okay, so one thing is please pay attention to basically increments when you're reading a graph. So what I mean by increments is look at your x. Is it going up by 1? So in this case, it's 1, 2, 3, 4, 5, 6. So that's easy, but then look at your y, how it goes up from 0 to 10 to 20 to 30. So that's just something just to watch out for when you're doing graphs, because those little things can get you. So line A, I would want to know what type of motion is line A. Well, if I look, my velocity is going diagonally upward at a constant rate. Okay, so that is going to be constant positive or forward. So same thing, basically going forward. Now, displacement, this little triangle D means I'm looking for displacement. That means I'm looking for my final position minus my initial position. So if I were to look up on this graph and see where would my position be, well, I'm going to be looking at the y-axis right here. So I want to know basically what is my change in y. Okay, so on my A line, my final position would be right here at 20. Okay, and my initial position would be right here at 0. So I know what's 20 minus 0, so that means my displacement would be 20 meters. Now, my time is basically how long did it take for line A. So I started at 0 seconds, ended at 4 seconds, so my time was 4 seconds. Now, velocity, what we've been talking about is your slope on a graph. Well, we just found our change in y and our change in x, or we just found our rise of a run. So velocity equals displacement over time. Okay, so our change in y over change in x. So 20 divided by 4 is going to give me 5 meters per second. Okay, my line B, now that's a flat line, so that means there's no slope, so that's going to be a no motion. Okay, so if I looked at my displacement, now we're just doing this for kicks, okay, because I want you to kind of get in the habit of finding displacement. It's always your final minus your initial. Well, my final was at 20 meters, and my initial was at 20, so 20 minus 20 gives me 0 meters. Now, how long were we standing still? We started at 4 seconds, ended at 7 seconds. So that means it took us 3 seconds for that period of no motion. Now, 0 divided by 3 is going to give me 0 meters per second. Now, line C, okay, we're going to look at what type of motion this is. We're going back up again at a constant rate. So this is going to be constant positive. Okay, and we're going to find our displacement. So where did we end? What was our final? So our final is right here. That's right there at 30. Now our initial is line C. So the initial was 20 right here. Okay, so a mistake that we can see is sometimes students will go back to the original, like 0, 0. Now that was the true initial. But if we're looking for line C, all I care about is line C. Okay, I don't care about B or A or D and like that. We're just looking at that. So my final is 30, my initial is 20, so 30 minus 20 is going to give me 10 meters. And then how long it took? We started at 7 seconds, ended at 9 seconds, so that was 2 seconds. So 10 divided by 2 gives me 5 meters per second. Now line D, if you notice, this actually looks a little bit different. So it is going down at a constant rate, but it's going in the negative direction. So this is going to be a constant negative direction, or it basically means you're going backwards at a constant rate. Now, as far as displacement, we're going to look at our final. Our final is going to be right here down at 0. And my initial was all the way back at the top right here at the 30. Okay, so it's always going to be final minus initial. Okay, so it's going to be 0 minus 30, which is going to give you a negative 30 meters. Okay, the time it took, we started at 9 seconds, ended at 15, so that gap is going to be 6 seconds. I'm going to divide those two, and I'm going to get negative 5 meters per second. Okay, moving on to the next graph. Okay, we're going to do our line A, B, C, D, E, F, G, H, and I. Okay, so we're going to kind of go through this one a little bit quicker. Okay, so type of motion for A is going to be a constant positive. I'm just going to put positive there, so it's constant positive. Our displacement We ended at 6. Now watch out for your graph here. So if you look at your increments, you're going up by 2s, both on the x-axis and the y-axis. So just watch out for that. We ended at 6, and we started at 0. So 6 minus 0 is going to give me 6 meters. Okay, how long it took went from 0 to 2 seconds. So my time is 2 seconds. And I'm going to divide those two, and I get 3 meters per second. Okay, line B, I have a flat line, so that is going to be a no motion, so nothing's going on. Okay, so I don't change displacement at all, so my final was 6, my initial was 6, so 6 minus 6 is going to give me 0 meters. And we were standing still from 2 to 6 seconds is going to give me 4 seconds. 0 divided by 4 is going to give me 0 meters per second. Okay, line C, now we're going back down. So it is a straight line, okay, straight diagonal line, so it's going to be constant negative. Okay, so my final position is going to be 0. Okay, it's going to be 0 right here. And my initial position is 6. So 0 minus 6 is going to give me negative 6 meters. And it took us 2 seconds. Oops. 2 seconds. And then negative 6 divided by 2 is going to give me negative 3 meters per second. Now, if we look, line D gets a little bit steeper, so that means our velocity should go up. Okay, it is still a constant negative because we're going down. And then my final is going to be negative 10 minus my initial, which is 0. So negative 10 minus 0 is going to give me negative 10 meters. Now, it still took us 2 seconds for this, so my time is 2 seconds. So negative 10 divided by 2, negative 5 meters per second. E, got another flat line. So no motion. Okay, we already know our displacement's going to be 0 since we're not moving any position at all. Okay, and we were there for 2 seconds. And then 0 divided by 2 is going to give me 0 meters per second. Line F, we're going back up. Okay, so this is going to be a constant positive motion. Okay, and we're going to look at our displacement. Our final position was negative 4. So I'm going to write this one out. So negative 4 minus... we were at a negative 10. Okay, so minus a negative 10. Okay, when you minus a negative, you're going to get a positive. So negative 4 plus 10 is going to give me a positive 6. So 6 meters. And that took us 2 seconds. So 6 divided by 2 is going to give me 3 meters per second. G, looks like it's flattening out a little bit, so I should expect my velocity to go down a little bit. Okay, so we're going to look at our type of motion. Is going to be constant positive, so even though it's a little bit flatter, it's still constant positive. We're going to look at our final position. Our final is going to look like a negative 1, so negative 1 minus my initial, which was a negative 4. Okay, so negative 1 minus a negative 4, is that going to be negative 1 plus 4, which is going to give me a plus 3 meters. And we went from 14 to 16, so that's 2 seconds. Now, 3 divided by 2 is going to give you 1.5 meters per second. So again, we do not want to leave it in fraction form. We want to go ahead and solve that and get the number. H, looks like we have another flat line. Okay, so this is going to be no motion. Okay, and it took, so no displacement, so 0 meters. And that was staying still for 2 seconds. So from 16 to 18 was 2 seconds. And I'm going to have a 0 meters per second for my velocity. And last one, I. This is going to be a constant positive. Okay, and we're going up in the upward direction, so we're going to look at our change in displacement. So it's going to be, our final is going to be 0. So 0 minus, we were at a negative 1. So 0 minus a negative 1, that becomes a plus 1. So I have a displacement of 1 meter. And it took us 2 seconds, so 18 to 20. So 1 divided by 2 is going to give me a 0.5 meters per second. Okay, moving on to the next part. So we're going to do more conceptual stuff with these graphs. So a lot of you are getting good at calculating the slopes and nothing too crazy there. So now we're actually going to start asking stuff about graphs and how do you interpret them. So if I were to look at both of these lines, A and B, I would say they're both constant positive. Okay, they're both going at a constant positive rate or same in the upward direction. Okay, now A does look a little steeper than B, so A does have a higher velocity. Okay, so we'll see what these questions ask. So 1, at 7 seconds, which cyclist is ahead? Okay, and how do you know? Well, the way we know that is you would look at position. Which one's further in position? And your position is your y. Okay, so I have to look who's further in the position at 7 seconds. So at 7 seconds, B is right here, and A is right here. So I'm going to see who is further in position. That is going to be cyclist A. Okay, so you could put has further position. You can talk about greater displacement. Either one's kind of fine. As long as we can kind of get what you mean, okay, you should be pretty good there. Okay, 2, which cyclist is traveling faster at 3 seconds? How do you know? Okay, so remember we talked about slope equals velocity. So we're always looking at slopes when we talk about velocity. So we're looking for which one has the steepest slope at 3 seconds. Okay, that is going to be cyclist A. Okay, A's got the higher, steeper slope and B's flatter. So we're looking for a steeper slope. Okay, are their velocities equal at any time? How do you know? Well, if their slopes are never the same, and which in this case they're not, okay, you're not going to have the same velocity. So no, their slopes are different. So in that entire graph, they will never have the same velocity ever. 4, what is happening at the intersection of A and B? So we want to know what is going on right here in the middle. Okay, so just be careful. They're not going to have the same velocity because they don't have the same slope ever. We care more about what's going on here. So they're both at the same position. Okay, so they're at the same position. And it looks like A is passing B. So A is passing B. Okay, move on to the next one. So number 1, how does the motion of cyclist A on this graph compare to that of the A in figure 1, so the last graph we just did? If you go back and look at that other graph, they pretty much look the same. Okay, it looks like the same slope, both constant positive, looks the same to me. 2, how does the motion of cyclist B in this graph compare to the B in the last graph? So in this case, we see B is going the opposite way now. Okay, so it's going to be a constant negative. And if I were to look at their velocities, it looks like B's a little bit flatter, so I'm going to say that this graph, B has a lower velocity. Okay, it does not hurt to over-explain. Okay, and then 3, which cyclist has the greater velocity? How do you know? So again, we're looking for slopes. We want to know who has the steepest slope in this graph. Well, it looks to me it's going to be A, because it has that steeper slope. Now, one thing I've kind of talked about in class is what if I changed B to something like this? So this is my new B now. And I asked you which one is faster. Okay, in this case, B would be faster because, again, you're looking for slope to tell you the velocity. It does not matter if it's positive or negative. Okay, you're just looking for the steepest slope. Positive and negative just tells you which direction you're going. So if I had something going 20 meters per second, and something going negative 30 meters per second, I asked you which one's going faster, I would still pick this one, even though it's negative. Negative is just telling me it's going the opposite way. Okay, so that's just something to kind of think of there. So describe what's happening at the intersection of A and B. So again, looks like they're meeting up. Okay, so same position. And it looks like A is passing B, and they're going the opposite directions. So A is passing B, but they're going the opposite directions. Number 5, which cyclist has traveled further in the first 5 seconds? How do you know? So we want to know who has covered more ground in the first 5 seconds. So let me go ahead and clear up this line real quick. So if we look at line B, it started right here. Okay, and it basically just drops down that far. Okay, so not a huge change in position there. Okay, versus A in that first 5 seconds had to start at 0 and go all the way up here. Okay, so A is going to have more position to cover. So which cyclist has covered more ground? A. And I'm going to say further displacement. So basically that's saying that A had to change his position more than B. Now going on to this graph right here, we're going to compare A, B, C, D, and E, these slopes here. We're going to rank it from greatest velocity to least velocity. Okay, so we're looking for steepness, so definitely number 1 is going to be A. Okay, then looks like B is getting a little flatter. Okay, so it's going to be B. And then it looks to me like D is going to be number 3. Even though it's negative, it looks flatter than B. If we really wanted to get technical, you'd actually find the slope. We're not going to worry about it in this case. Okay, then E, getting a little bit flatter. So there's my number 4. And then C is that big flat line, so it's going to be a no motion. So that's going to be my lowest velocity. Okay, so that is going to be, the greatest would be A, then B, then D, E, and C. Explain your reasoning. What we're doing is you're looking for slope. Okay, that's how we're reasoning that, and you're ranking it from steep to flat. Okay, 2, what is happening when line A and D are crossing? Basically the thing we've been talking about the past 2 graphs. So what's happening right here when they meet? Okay, they are at the same position. And they are passing each other. So A is passing B. And that'll end page 14.